Have you ever stopped to think about the hidden senses that animals use to navigate the world? We're about to dive into one of nature's most mind-blowing superpowers, the ability of certain insects to actually feel and follow the Earth's magnetic field.
So, let's start with a puzzle that seems almost impossible. You've got the monarch butterfly, right? This tiny, delicate thing. How on earth does it fly thousands of kilometers all the way from North America to one specific forest in Mexico, year after year?
Well, the answer is straight out of science fiction. They're not just using the sun or looking for landmarks. Nope. They are tuned into an invisible force field that wraps around our entire planet. So yeah, today we are pulling back the curtain on one of biology's greatest mysteries. We're talking about the incredible, almost magical ability of insects to read the Earth's magnetic field. A sense so refined it lets them pull off navigational feats that, honestly, still have scientists scratching their heads. But here's the kicker. It's not just a simple north-south signal they're picking up on. They are navigating a living, breathing map. A map that's constantly shifting and wobbling with our planet's own magnetic heartbeat.
So what even is this field? Well, deep inside the Earth, there's a churning ocean of molten iron. And all that swirling metal generates a huge magnetic shield. Now, this shield is great for us. It protects us from nasty solar radiation. But it also creates this invisible web of information all over the globe.
And this is where it gets really fascinating. The field isn't static. It's not a fixed thing. It is constantly fluctuating. It wobbles. This is caused by everything from the core's churning to massive storms on the sun. And this wobble, these tiny little changes, are exactly what these insects are reading.
Just to give you a sense of scale, the average strength of the magnetic field you or I experience is about 50 microteslas. That's already incredibly faint. You and I can't feel it at all.
But the wobble, the tiny shifts these insects are detecting, we're talking thousands of times weaker than that, down in the nanotesla range. I mean, that is an absolutely insane level of sensitivity. So, how do they do it?
Okay, get ready, because the first explanation is a trip. It takes us right into the truly bizarre, mind-bending world of quantum physics. The idea is that some insects have a compass that is literally built from the strange rules that run the subatomic world. The key player in this whole quantum show is a protein called a cryptochrome. You find it in the insect's antenna, and we know it's sensitive to light, but scientists think it's doing something much weirder. It's a process called the radical pair mechanism. Stick with me here. It works like this. When blue light zaps the protein, two of its electrons become quantumly entangled, linked in this spooky way. The Earth's magnetic field, even its faintest wobble, actually affects how those electrons spin. That change then kicks off a chemical signal that the insect's brain can read as a direction. It's basically a biological quantum computer. Wild.
But wait, just when you're wrapping your head around quantum biology, it turns out that might not be the whole story. There's another system, a much more mechanical one, that's likely working right alongside it.
This second system uses magnetite. And what's that? It's basically tiny, naturally magnetic crystals of iron that are embedded right there in the insect's body. These little crystals physically twist and turn to line up with the planet's magnetic field, just like a microscopic compass needle would, sending signals to the brain about which way is which. So it's probably not an either-or situation. It's very likely these two incredible systems work together as a team. The magnetite gives the insect a general, stable sense of direction, like a basic compass. And then, the quantum cryptochromes act like a super-sensitive fine-tuning tool, detecting all those subtle wobbles for making precise, real-time adjustments. It's a beautifully complex navigation system. And this amazing ability isn't just for monarch butterflies. Oh no, this magnetic sense is all over the insect kingdom, and it's used for all sorts of incredible behaviors. Honeybees, for example, use it for super precise, short-range flying. So on a cloudy day, when they can't see the sun, that internal magnetic compass helps them find their way right back to the hive, no problem. And then you've got termites. Get this, they use the magnetic field for architecture. They literally build their huge mounds along the north-south magnetic lines. It's not for travel, it's to perfectly control the airflow and temperature inside their homes. How cool is that? For locusts, it's all about staying together. That magnetic sense is what helps coordinate the movement of millions, literally millions of them in a single swarm, making sure they all fly in the same direction. It's the ultimate crowd control. And of course, for bugs that fly at night, like moths, this sense is an absolute game changer.
When the moon and stars are hidden by clouds, that magnetic map is a reliable backup that never disappears.
But, and this is a really important but, this ancient, finely tuned superpower, which has been perfected over millions of years, is now facing a bunch of brand new threats, human threats.
Think about it. All the electromagnetic noise from our power lines, our cell towers, our Wi-Fi, it's like constant static that can drown out those faint natural signals they're trying to listen to. Add in climate change messing with weather, and the fact that the magnetic poles themselves are moving faster than they used to, and their map is suddenly getting very confusing.
And this has profound, real-world consequences. This sensory disruption is very likely a factor in the decline of crucial pollinators. I mean, if a bee gets lost because its internal compass is scrambled and it can't find its way home, that directly impacts our ecosystems and, yeah, even our food supply.
It just leaves you with this powerful thought, doesn't it? These tiny creatures, they're like living biological instruments, perfectly tuned to read the magnetic heartbeat of our planet in a way we're just now starting to appreciate.
Which brings us to a final, really critical question. As our world gets electromagnetically louder and louder, are we accidentally silencing nature's oldest, most sophisticated navigators? It's definitely something to think about. Thanks for joining me on this one.